So, hey guys, today we are going to solve a Leetcode problem which is based on binary search on answers. So, let's get started. The problem's topic is split array largest sum. So, you are given an array nums and you are given integer k. You are told to split the array in k number of partitions and you have to return the minimized largest sum. So let me explain you with a test case. So let's say this is our array and we are supposed to split it into two partitions. So what are the possible partitions the array can be split in? So it can be split in 7 and 2, 5, 10, 8. So it will be 7 and 2 plus 5 plus 10 plus 8, which is our almost like 25 or something, right? Which is 25. So 7 and 25. So here the maximum sum becomes 25. So we have to split the array in such a way that the maximum sum would be minimum. Like we can split the array such a way that it will be 7, 2 and 5 and 10 and 8, which is 7 plus 2 plus 5 is uh, 14 and 10 plus 8 is 18, so the maximum sum is 18. So that's the most optimal way. Let's take another test case. Let's say you have this array and you have to split it in two partitions. So what can we split in? We can split it in 1 2 and 3 4 5. We can split it in 1 2 3 4 5. So what are we going to split? So we are going to split it in 1 2 3 and 4 5, which is 1 plus 2 plus 3 is 6 and 4 plus 5 is 9. So we have minimized the maximum sum, which is 9. What is our approach going to be? Our approach is going to be quite easy. If we have solved the previous problems like book allocation and all, the pattern is almost quite similar and I hope you will understand. So our logic is such that we a book, let's say the minimum, what will be the minimum maximum sum, which is like at least 5. The sum will at least be 5. And what will be maximum that can be allocated? It can be the entire sum of the array. The answer is going to lie between this range. So first we will decide our low and high. So our low is going to be the maximum in our array. Let's just find our maximum in our array, as but the array is not sorted, so we have to find it separately. uh, and our sum, we have to calculate the sum as well. So let's start a for loop. Okay, so here our n is length numbers. So first basically we are going to calculate the maximum element in the array and also the sum of the entire array, which is so this is going to be our low and high. So our low is going to be our maximum element in our array and our high is going to be sum. So let's start our binary search. While low is less than equal to high, we are going to calculate mid. Now we are going to check if our mid, if we are supposed to have a specific sum, maximum sum, how many partitions are we going to require? So let's create a function. So I will explain you the logic in function. Let's create a function is valid, and it basically checks that if we are supposed to divide our array in k number of partitions and the maximum sum should not exceed the mid value, is it valid or not? So we are going to check that. So it will require our array and also the number of partitions, and also we will require our mid. So determine what is going to be the maximum sum that we are allowing. So yes, if our answer is valid, what we are going to do is we are going to check if any smaller for any smaller sum is it possible or not. So we are going to move left, y equal to mid minus 1, else low equal to mid plus 1. So our array is basically like, our answers are basically like, sorry, uh, it starts from being false and then becomes true. So for more number of, so if we are allowing the sum as more, we know that it is always going to be valid. And as the sum reduces, maximum sum allowed reduces, we are going to require more number of partitions. So that's the case. So this is how our answers is going to be. At last, as I said, for this we always when we are going to check for minimum, we return low. Okay, so now it's time to for our function public boolean. So it takes an array, it takes our the number of partitions we are supposed to make. Let's name it partitions, and this is going to be our max value. So we are going to iterate through the array. Now we have to check. This is similar to the book allocation problem one. So what we do here is we maintain a variable, let's say load. So our load is initially it is 0, and let's maintain a count. This will maintain this will tell us the number of partitions that we are requiring. It will be initialized to 1 as first count has already, first partition will always start even if it will require at least one count, one partition to get the entire array, considering the array is not empty. So we check if our load plus arrays I value is greater than our allowed value, We know that it has exceeded our allowed value, and now we have to increase our partitions. So the first partition has completed. We are at the second partition officially, and our load will still have that extra value, which is current array value. Else you can just keep adding the elements in the array. And for early checking, we can check that if our load at any point exceeds our, not load, if our count at any point exceeds the maximum, exceeds our partitions, if it at any point exceeds our partition, we know that this will require more partitions than we are able to allocate. So this is obviously return false, and we have to move right. We will increase the value that one subarray can hold, and once we are successfully out of the for loop, we can return or true. And I think that's it. So yeah, this is accepted, and I know I know I have to improve my explanation skills, but thank you for listening, and I will see you guys in the next explanation. Thank you very much.